Hi everybody. I can talk again and I sound almost like a normal person, so I'm really excited. A few of you asked for a review of the distributive property. Specifically, what did we do last semester and how is it related to what we did this semester? So I wanted to show that to you. So the first thing that we did last semester is we used the distributive property to simplify an expression. And what we had to do was take the number in the front and multiply it by both pieces inside the parentheses. And we knew this because when we drew a generic rectangle and we did 3 times 5 plus 7, this part right here is equal to 3 times 5, and this part right here is equal to 3 times 7. Then we actually multiplied it out and we got 15 and 21. And when we add it together, we get 36. The same thing works with subtraction. If you take the number in the front and multiply it by both pieces, we have 8 times 9, and this time we just need to be sure that we are subtracting 8 times 4. So 8 times 9, I believe, is 72, minus 32 would give us an answer of 40. Now what we did this semester is we said, well, what if instead of 2 numbers, one of my numbers is still unknown? The same thing applies where this first number gets multiplied by both pieces. We end up with 5 times x plus 5 times 4. And this can be seen with the algebra tiles that you build. This says build 5 groups of x plus 4. So 1, 2, 3, 4. That's 5 x's, and then each x, I'm just going to do lines instead of boxes because they're going to take forever to draw. Each x has 4 units attached to it, and so I see 5 x's, and I see 5 groups of 4. My groups of 4 are all here. We can take this one step further to be fully simplified, and that would be to say, hey, I can just write this. I know there are 5 x's, and I know if I count all of my units at once, altogether there's 20 of them. This also works when you have multiple x's, and subtraction signs still hold true. This said build 2 groups of 3x minus 2, so there's 1 group of 3x's, 2 groups of 3x's, and then each of these has a minus 2 with it. So altogether, I see 6 x's, and I'm subtracting 4 because I have 1, 2, 3, 4 ones that I'm subtracting. So this is equal to 6x minus 4. The last thing that we did is we decided what happens if we are given an expression and we want to find out how to group it. And we started doing this using algebra tiles. So what it would look like to have 9x tiles and 12 unit tiles and to split them evenly. Can I split them into groups of 2, into 3, into 4, into 5, into whatever? But what I'm going to encourage you to do actually is the same thing we did for greatest common factor. If you put your 9x in one of the boxes and 12 in another box, this x might be freaking you out right now, but it actually doesn't really do anything. You can hang it off to the side, it's not very important at the moment, and focus your attention on the 9 and the 12. I know that 3 is a common factor of 9 and 12, and that 3 times 3 is equal to 9, and 3 times 4 is equal to 12. So this means that up here is the number of groups that were created, so that's the number that goes in front of the parentheses. And on this side over here is what is inside of each group. So this is in each group there are 3 x's and 4 unit tiles. And if you were to draw this out using algebra tiles, you would see that it does in fact have 9 x's and 12 unit tiles. Last one, 10x plus 15. If we do this method and we go 10x and a 15, I'm going to ignore my x for now and I'm just going to focus on my numbers. So I've got a 10 and a 15. Those definitely both have a 5 in common. 5 times 2 is 10 and 5 times 3 is 15. I have 5 groups of 2x plus 3. And that practice is called factoring. Okay, so I'm going to skip the next slide real quick and then go back to it. So, one of the things that they like to ask on like the state testing is click all of the answer choices that apply. So there might be like 4 boxes, and one of the choices might be 2x plus 3.4. One of the choices might be 2 times x plus 3.4. Maybe we have a 2x plus 2 times 3.4. Maybe a 2x plus 6.8. And what you need to be on the lookout for in these is all of the different possibilities that work. One of the ones that people tend to immediately ignore is this last one, because they're like 6.8, I don't see that anywhere. But if we were to multiply this out and we were to look, if we filled this one out, multiply 2 times x, we would get 2x. And in this one, we would get 2 times 3.4, which would give us 6.8. So this 2x plus 6.8 does work, because when everything is multiplied out and simplified, you have a 2x and you have a 6.8. So that one would be checked. Another one that people commonly get wrong is they say, ooh, I know that 2x is right, because they figure out this box, and they're like, and then I have a 3.4 over here. But the insides can never be meshed with the outsides. You can't have an inside part that's 2x and an outside part that's 3.4. You either have to have all inside parts or all outside parts. So this one does not work. This one right here does work. The 2 is the 2 at the top, and the x plus 3.4 is the whole side if you put it together. And then the final answer choice, this one right here, the third one, also works. The 2x comes from the inside piece up top, and then the 2 times 3.4 comes from this inside piece, but before it's actually been multiplied. If you look up to the top and follow our arrow, we are seeing our 2, and then we're multiplying that by 3.4. So this is a problem that even if you know the distributive property really well, if you're not told to look for the distributive property, that you might forget to be on the lookout for it. So just be aware anytime that there's like problems that have parentheses in them and then some that have no parentheses, you should probably be looking for any of the relationships between the distributive properties that you can. So here is your list of problems. Again, it should probably take you like 2 or 3 minutes at most. Maybe it might even take you like 30 seconds. But if you have any requests for things that you want to review that you may have forgotten, first check the channel to make sure that there's not a video already up there. And then you're welcome to let me know, and I'm happy to make a video for you so that you can study as best you can. So yeah, just let me know what you need. And I will stop coughing soon, I promise. I'll see you in class. Bye.